All right, well, good morning, everyone. Thank you for joining Flex Train, a training opportunity brought to you by Johnstone Supply. So we were originally going to do some load calculation discussions for the next couple of weeks, and I think we're going to take a little detour away from that right now with the resurgence of positive cases around the country. We wanted to talk about some home IAQ and things that we can do to help detour COVID-19 in our spaces. So if we look at COVID, not from the aspect of how it affects us physically, but how it's actually constructed and how we can deter it from being in our spaces. So, COVID-19, like many viruses, is just a composition of different proteins, and it has a molecular size to it. So if we look at COVID from the filtering aspect, we just need to look at how small is it, right? So if we look at a typical COVID molecule, it's going to be around 0.125 microns. So we've seen research on doing air filtration to reduce the interaction with COVID. And we're finding that higher air changeovers in the facility is a very important thing. Bringing in more fresh air and keeping those air turnovers higher, decreases the amount of particulates that are in the air. But if we think about how small those things are, those are really, really small. So, we have a lot of people that are going out and buying very expensive filters from the box shops, which are incredibly bad on your ductwork, and, thinking that they're going to be able to use a high quality filter and filter out these particles. Well, if we look at what most filters are capable of, so think about that. We're going to be trying to filter 0.125 microns. We can filter down that low, but our systems are not really designed for it. So this is an independent filter research from Lake Air, so lakeair.com. They do a lot of quality lab testing of a variety of filter medias. And if we look at most of the filters that we're going to see in our typical residential and in light commercial industries, what we're going to see is, the least expensive filters are the aluminum mesh and the fiberglass mesh. Those things are not even efficient at those particles above 3 microns. So those are 100% out all the way across the board. If we look at what we consider our cheapest disposable, so that would be from our basic fiberglass into our pleated, that is going to be this section here, which is what most of us tend to use on our furnaces. Those are the ones that actually keep our static pressure within operating range most of the time. And with those, even the best of those in the MERV 8 ratings are only going to be 70 to 85% effective on molecules that are 3 microns and greater. Not effective at all as we get down into the 1 to 3, and then they say below 20%, only because it varies on the construction and how the filter places inside of your rack. But definitely less than 20 no matter what. So then we get into our very, very premium filters that we're going to buy from our box shops, right? These are our 3Ms. These are our very dense pleated filters that add an incredible amount of static pressure. Most of these filters already have more static than your entire duct system was designed for. So good filters for filtration, very bad filters for your HVAC system. And even with those, so those are going to be 85 to 90% for molecules that are 3 microns or larger. Even the very best of those do not qualify down into the 1 micron and under. So the only ones that are even going to qualify to get us in that 1 micron and under range are going to be those MERV 13 and above. And residential applications are just not designed for MERV 13 and the MERV 16 rated filters. We use most of those for commercial and industrial applications with very oversized ductwork that can handle some additional static pressure. So in the field that we live in, you can go out and buy the best filter that you can find, and you're still not going to be very effective, because even that MERV 13 is less than 75%. That MERV 16, the highest graded filter that we can find, it does have a 95% or better, but you're going to have so much ductwork and you're going to have to be required to have high static blowers to even handle the static pressure on these style of filters that it's just not feasible. So filters alone are not the answer. Filters always help. Air changeovers will help more than anything. And then now we need to take a look at what are our other options. What can we do? Because IAQs came a long way, particularly in the last 10 to 15 years. So we have a variety of different manufacturers of components out there, but we have different technologies. And that's what I want us to look at and what the different technologies are doing, right? So if we look at the most popular IAQ treatment, that's going to be ultraviolet, right? UV lights. So with ultraviolet radiation, what we're doing is we're using a spectrum of the light, and that's typically around 264 nanometers. So that is the frequency of our light that's being produced. If we look at the UVC spectrum, that's the 200 to 280 nanometers. That's what most of our UV bulbs are producing, is they're producing frequencies of light in that range. And what that does is it does help to destroy the internal composition of our microbials. So if we look at the DNA structure of most of our viruses, what we're going to do is that UV light is actually going to destroy some of the DNA chains, some of the links within the DNA structure. Right? So like that thymine, we're going to actually do some destruction of the DNA with that frequency of light. So it will help to destroy it, but more important, it destroys its ability to reproduce, right? That's how our viruses grow. They reproduce. So with ultraviolet radiation in the C spectrum, we're going to destroy some of those chains within the DNA that's going to keep the virus from reproducing. So we're going to have a very, very significant reduction in the reproducing of that DNA of our virus. So very, very popular treatment. We've seen that as a widespread IAQ in our grocery stores, food production facilities, restaurants. All of our lab facilities are now using UV light for treatment. So it is very effective. And depending on the strength of the bulb, we're going to have different effectiveness and how much air turnover we use, but at least it is something that definitely will destroy viruses. So that is a very popular one. The one that has really came into the residential industry hot and heavy in the last few years is ionization. So ionization actually kind of started taking some of its roots in our early electronic air filters. So what we would do is we would use a transformer to produce a polarity, to produce positive and negative ions on our field, on our screen. So what it would do is when we create the ionization effect, when we create that additional positive and negative ions, it adds density to the particles that are coming through. So as those particles would pass through our energized screen, it would add density to it, and we would collect them typically with some static electricity, right? So that principle has moved into a slightly different design where we can actually introduce those charged particles into the airstream. So we do a high energy ionization where we add positive and negative electrons to the air stream, and those will actually bond with dense particles that are in the air to create weight, and we will drop those down. We will release those out of suspension in the air. And that is one of the most common methods that we are using now for air quality treatment is ionization. So these are products like iWave. That's their key component, is that they're doing a large scale ionization. Even products like the Remy Halo, which we'll talk about here in a minute, is using ionization technology. So there's a variety of manufacturers that's using ionizing products. And I will tell you that it is a very significant difference. So I installed at home an iWave when I first moved into this house. This is new construction, so there's still, a lot of, dust around from construction and, mean, pretty clean environment, but you still get drywall dust, and you get a variety of odors and aspects to the home. And I had a dog, right? So I had a flat coat retriever, which is a fairly long-haired dog, and there are lots of dander and lots of hair. And one thing that I noticed by using an ionization in the house was that, typically on a summer day, the dog comes in from outside and does a little shake off, and you can see particles in the air, right? And we can see our dust floating around. Almost immediately, I started noticing that that wasn't happening, that the light coming through the windows was staying very clear. And I did notice a buildup of dust around the home when I first started using the product, and which subsided after about a week or so. So it was really proven to me that it was reducing those suspended particles. And now you can walk in my home and you don't know that there's even a dog in the home. There's zero odor of a dog. So it's taking those particles, it's adding weight to them, and it's getting them out of the air. So if we think about that from a virus and a bacterial aspect, that's what we want to do. We don't want to breathe in those particles that are up here at 5 or 6 feet off from the ground. We want those particles to be down on the floor, on the ground. And that's what we do with an ionization technology. So we have other products that are, and other technologies that are being used. If we talk about the photocatalytic oxidation, we're still going to need a UV light. So we're going to use some kind of a catalyst, which is going to be like the photocatalyst material that's going to absorb some of the UV. And then we're going to go through a process where we're going to create some hydroxyl radicals, so oxygen and hydrogen molecules. And then those molecules are going to bond with our pollutants and our bacteria, and it's going to do internal destruction of that cell membrane. So now we're going to actually concentrate on the membrane of that cellular structure to help break it down, so that when it breaks down, because remember, most of our bacteria and viruses, are just chemicals to begin with, right? So all we're going to do is we're going to try to destroy those chemicals so that they're not reproducing again. So you'll see some photocatalytic oxidation products out there as well. We also have a photohydroionization. I only know of one product line out there right now that is using that, because it is a proprietary process. And with it, so we're going to do a similar type of oxidation where we're producing the hydrogen oxygen molecules. It's a slightly different style that's using a photo production. So it's using a light band to help produce the hydrogen and oxygen, and those are advanced hydroxide radicals. So those are H2s and O2s. And so in that, as we go through that change in photolysis, we're going to break down those molecules even further into individual hydrogen oxygen compounds that can penetrate through the cellular core, through the actual membrane of that cell, to destroy it. So we can do ultraviolet radiation to help destroy DNA. We can do added weight and suspension of the molecule through ionization, and we can now actually start working on destroying the membrane of the cell. So there's different technologies, and it's important to know how each one of them works. So I'm just going to focus on our two most common IAQ products that we sell at Johnstone. So we sell the iWave and we sell the Remy Halo, and they're very different. They have similar characteristics, but they function in different ways. So iWave had one preliminary test result that was, it was actually based against the SARS-CoV-2. So not exactly the strain that we're focusing on as much now, but it was just showing the effectiveness of destroying a virus by using ionization, heavy ionization technology. And if we look at that, we took that SARS-CoV-2 virus and in a time chamber had about a 99.4% reduction in those suspended molecules after 30 minutes. So that's pretty significant. That is it's a lab result of what we are doing with ionization. We're adding density to that molecule so that we can get it out of the air, so that it is not suspended in the air that we are breathing. And like I said, I just installed one of those here a couple days ago. We're going to be doing some testing on that. So there's a lot of independent test results out there. So I encourage you to look at your own test results and make some conclusions of what products are best for you.
With the iWave, they've got a couple different styles. They are a needle point bipolar ionization, so we're using 2 poles that that are producing our ionization. We also have one that is a self-cleaning model, and that's the one I like. It actually has a small motor, the servo, that goes in and cleans the tips periodically. It's pretty cool. I actually like the component quite a bit. So what they're showing you that they're doing is they're bringing in not just our viruses and our bacteria. We're also focusing on things like dust, smoke, mold, and adding that density to them so that we can reduce them out of our atmosphere. But remember, anytime that we're doing ionization, you are going to need to change your filter more often and use a quality filter. So not a MERV 13, but a quality disposable. I recommend a disposable pleated filter myself, or a high quality disposable fiberglass. So that's the iWave, that's the R, that's the actual self-cleaning model. So then we get into the REMI Halo. So REMI Halo has a variety of things going on with it. So they are using bipolar ionization. So they're using a similar principle or same principle that the iWave is doing. And then they're also using the photocatalytic oxidation. They're using ultraviolet, which is really cool. And now they're using their photohydroionization, which is proprietary. And I don't know a ton about it because it is proprietary. All I did was got a little bit of research from what photohydroionization does and just have an idea. So it's still using a photo process to break down molecules. And so we have all of that going on inside of the REMI Halo. So I have contractors that prefer the iWaves, and I have contractors that prefer the REMI Halo. So that's what we have, and that'll be up for you to decide what style of IAQ works best for you. I can vouch for what the iWave has done for me, and we will probably be installing the REMI Halo on one of my additional systems here at the Indy West branch, so we can take a look at that. The REMI has a lot of third-party verification for their products. So they will report a 99% destruction of viruses and bacterias, such as or similar to the novel coronavirus. So very important stuff. And that's just a little bit of specifications on that REMI Halo. And all of the things that it is working to destroy in our air. So even things like listeria and salmonella and C. diff and Norwalk virus. So a variety of different viruses. Now, any questions or comments on IAQ products for the destruction of coronavirus? Paul, I can't believe you don't have anything to comment on IAQ products.
Yeah, I've spent a lot of time with IAQ when I was in the field, and the PCO is probably what we had put in the most, UVC with some PCO, and just a comment, I guess, is definitely remember that there is maintenance required to these. So yes, there is a bulb life, and they do get weak, and so when you're selling these products, make sure you're communicating that clearly with the homeowner. It definitely will help. It is a very good products, but there is some maintenance that is required on these as well.
Yeah, I think that REMI Halo is recommended every 2 years for new life replacement. Yeah.
Yep. 2 years is pretty common.
Even for UV, 2 years is pretty normal. So adding IQ does help a lot. It does add maintenance, but in our industry, that's job security as well.
Yeah, and with allergies and the viruses that are going around, and the concern of IAQ is going up dramatically, right?
Yes, it is.
So don't just assume that homeowners, because there is an expense to installing it, there is an expense to maintain it, that they devalue what it can do for them. People are really concerned with IAQ. So if you don't offer the product, then they don't know about it. They don't know that you sell it, and
that's right.
But they may want it. So don't read into that, and just offer it and let them do it.
I was talking to a new Calgon representative back in around April or May, and they had a significant surge in sales in their air quality treatment products. So, and I assume that is probably still going. So, all right, well, everyone, I thank you for joining us this morning, and I don't know what we're going to do next week just yet. I think I'm going to break away from the load calculation, and we will, I don't know, next week will be a surprise. So everyone have a great day, and we'll see you all next week on FlexTrain.